Okay, welcome grade 11s and 12s back to chemistry. So what we're going to go over this week is really two lectures. The first one's going to be on balancing chemical equations. Now, I know some of you are put off by this and hate balancing chemical equations, and I totally understand your pain. It can be frustrating because there's not really a set way of doing it. It's not like, oh, I do step 1, step 2, step 3. It can sometimes, you can get it done in a minute, sometimes it takes you 20 minutes. It's just all kind of trial and error. So this is not a major part of the course. I mean, you should recognize if something's balanced, but I'm not going to be requiring you to do a ton of balancing of equations. Specifically, the 12 C's, it'll be more of, is this thing balanced? You have to balance some simple ones, but more, is this thing balanced? Now, the 11 U's, I will require you to balancing, but not all the time, okay? Because, again, we have online balancers, but I do need you to be able to do it manually. Okay, so balancing chemical equations. So last week we worked on creating chemical equations in both word and skeleton form. Now word equations they should be kind of relatively simple. You're basically just kind of taking out a sentence and then putting it into words. So a word equation is kind of like what I have here, okay, where hydrogen plus oxygen leads to water. And we're basically just using the words, and we're putting a plus sign and an arrow sign in there to indicate that these are the reactants, and hydrogen and oxygen are the reactants, and water is the product. Okay. Now, a lot more beneficial, especially for chemists, is a skeleton equation. Okay. Now, these are a little bit more complex because you actually have to understand, well, what is hydrogen? What's the symbol for hydrogen? Oh, it's H. And then also having to understand, oh, hydrogen can never be on its own. It has to be H2. And oxygen also can never be on its own. It's O2. Okay. And then the formation of water, that it's H2O. Okay, so skeleton equations kind of require a pretty good chemical background. Okay, you have to be somewhat understand chemistry in order to be able to make a skeleton equation. Okay. Now, this week we're going to explore the most important form of a chemical equation, which is the balanced. All it is basically a skeleton that takes into account the number of atoms on the left side of the reaction and on the right side. Okay. So here's the advantages of balanced chemical equations. 1. They take into the account of the quantities of the reactants required for the reaction. Okay, if you're going to produce, so like say CO2 and H2O down here, okay, it takes into account, well, basically how much of this stuff do I need? Okay, it takes into account that I needed 2 oxygen molecules, not just 1. Okay, in order to make this reaction work. So that's why it's so important. Is it's actually explaining to us the chemistry, and it's telling us that you can't just use 1 oxygen molecule. This process won't work. You need 2 of them. So that's the first point. It takes into account the quantities of the reactant required in the reaction. Okay. Now the other thing it does is it takes into account the quantities of the product being produced. It also tells us that we are going to produce 1 CO2 molecule and 2 water molecules every single time we do this process. Okay, and the fact that we have 2 water molecules it's making sure that it's balanced, and it's telling us that we're not going to produce 1 water molecule. That's impossible. You'll always produce 2. Okay, and then the last part, and this will get a little bit more important as we go through kind of the course. Especially when we get into math, it's required to perform any chemical calculation. If you're going to do some chemical calculations, you have to have a balanced chemical formula. Without using a balanced chemical formula, it's very difficult to use a lot of the calculations we use in chemistry. So it's important to have it. Okay. So just some terminology, and there's only one term that you need to know for this, and it's the term coefficient. So balanced chemical equations contain what we call these things called coefficients. Okay, I'm just going to highlight this word here. Now, what are coefficients? Which are the numbers placed in front of the chemical formula. So this is a coefficient right here. That's a coefficient. And although there's not a number here, if there's no number, you can always assume that it's 1. Okay, I don't know why I chose such a huge pen there, but that's the number 1. Okay, so those are our coefficients. And they're the numbers placed in front of the chemical formula indicating how many of that atom or molecule you need or are producing. Okay. Now, coefficients can be changed. These things you can alter. Okay, you can decide, oh, I want to change this 1 into a 2, or this 2 into a 4, and so on. Okay, so coefficients can be changed. So I can change this 3 to something different, like a 6 or a 5 or whatever I want to change it to. I can change these numbers when I'm trying to balance. What I can't change are these numbers. when you are balancing chemical equations, you can't change these. These are stuck. Okay, so you can't change the little numbers, but you can change the big numbers in front. Okay, and what these numbers, these coefficients really are representing is it's basically saying 1 and 2 molecule. Okay, so the number 1 and 2 molecule has to react with 3 H2 molecules. It won't work unless you have 3 of them. So 1 and 2 has to react with 3 H2s. And if you have the 1 and 2 react with 3 H2s, you're going to produce 2 NH3s. Okay? Now, a very kind of simple thing to see if you understand this is, well, what if I had, let me just take this for a second. What if instead of 1 N2, I had 2 N2s? Well, if I have 2 N2s, how many H2s am I going to have to have? Okay. If every time I have 1, I need 3 of these, well, now I have 2 N2s. So how many of H2s am I going to need? If you really get it, you understand that, well, now I would need 6. Because every time I have 1, I need 3. But since I have 2 N2s, that would mean I need 6 H2s. And how many of these am I going to produce? Well, then you would produce 4 of these. Okay, you're basically just doubling everything all the way across. Okay, so let's go through some balance. Now, balancing chemical equations can be frustrating as there's no step-by-step instructions. It mostly just comes by trial and error, looking at numbers, plugging them in, and then trying it and seeing if it works. Okay, now, we've got to remember a couple things, that most coefficients will be 1, 2, 3, or 4. It's very rarely they're ever going to be anything higher than that. If I did give you anything higher, it would be on accident. Okay, all the coefficients should be 1, 2, 3, or 4. And there's a few ways that we can make this process easier. One, we're going to make a balancing chart, so a left side and a right side, and I'll kind of go over what I mean by that. And then the next thing is to kind of balance the odd elements first. You don't really want to balance carbon or hydrogen. Those are too common and they're all over the place. But if you get something weird like, oh, I have a sulfur in this one, or I have a lead, you kind of do the odd elements first, okay? Or any kind of compounds first. And I'll get to that when I talk about polyatomics, because we want to keep the polyatomics together. That's going to really simplify things as well, and I'll go through a couple examples. Okay, so let's take a look at our first one here. Okay, so I'm just going to get a pen here, and I'm going to shrink this down. Okay. All right. So we have Na plus Cl2 leads to NaCl. And if we look, this is not balanced. Okay. Now, how we're going to balance this, I know this is a very simple one that you could probably do by looking at it, but this is, I'm going to explain the process here. This is what you would do to balance it. What you basically say is, I'm going to look at this arrow here. So I want to highlight this arrow right here. Okay. And I'm going to do everything from the left side and the right side. So on that left side right now, what I have is I have 1 Na, I have 1 sodium, and I have 2 chlorines. Right? That's on the left side. Now, on the right side, I have 1 sodium, so that's good, that matches up, but I only have 1 chlorine, so that does not match up. So what I have to do now is I have to basically start putting in coefficients and trying to make them match up. So when I look at this and I say, okay, I need 2 Cl's on the right side. Well, I can't put a number. I can't just put a number down here and say, oh, I'm just going to put a 2 there. Okay, it's balanced. We can't change those numbers. Those are stuck. Okay, remember that we have the crisscross rule. So we can't just put a 2 there. Okay, so let me just erase that. But what we can do is we can put a 2 right in front. Right? And I'm sorry I didn't leave enough space there. So let me kind of write this over here. We can do this. We can say Na plus Cl2 leads to NaCl. And I'm going to put a 2 in front. Okay, that's a horrible color. So let's have to keep it with the black. A 2 in front. Okay. Now, once we do that, we have to go back now and we have to readjust our chart. So now what I see here is now on the right side, I don't have one Na, I actually now have two NAs. Okay? 'Cause that 2 is now in front of two NAs, and now I also have two CLs. Okay? So now the CLs have matched up, but if I look back and I realize now the NAs don't match up, I only have one A on the left side. But I can go over here, and again, you can put numbers in front, you just can't put them down on the bottom. And now if I change that, and I say, okay, if I put a 2 in front of there, then I'm going to have to go back. Okay? And that changes that to now 2. And now I've got two NAs, and I've got two CLs on both sides, and this one is balanced. Right, now this one was a very, very easy one, I realized that. So that's why we're going to go to our next one, which is much more complicated. Now I'm going to redraw this out because it's a little bit nicer when you actually have the numbers in the right spot. So we've got Al plus H2 SO4 leading to Al2 SO4 plus hydrogen. Okay. All right. Now, we want to try and balance this. Okay, so we're going to do the same kind of thing. We're going to do left side and right side. Okay. All right, so we got the left side and our right side, and let's go through and say, okay, what's on my left side? So I take a look at my arrow, which is right here, and everything on the left side, I've got one aluminum, I've got two hydrogens, and this is what I mean by keeping the polyatomics together. We've got one, and I'm going to keep this whole thing together, one SO4. Okay. Then on the right side, I've got two aluminums, I've got, that should be a 3. I've got 3 SO4s, and I've got 2 H's. So when I look across here, I look and see, okay, I've got two problems here. Okay, I look and I say that my aluminums aren't matching up, and I also notice that my SO4s aren't matching up. The number of hydrogens is okay. Okay, so what I'm going to do is I'm going to go to the SO4s first. They're the kind of the weird ones, so I'm going to try and balance this. So right on the right side, I've got 3, and over here, I've only got 1. So what I'm going to do is I am going to simply put, I'm just going to redraw this, aluminum, aluminum plus, and now I'm going to put a number in front, and I need 3 SO4, so I'm going to put a 3 there. Okay. Well, as soon as I put that 3 down, now I have to readjust all these numbers. Okay, I've got to readjust all these numbers and say, okay, how many aluminums do I have on this left side? Oh, I still have 1. That hasn't changed. How many H2s do I, or how many hydrogens do I have now? I have 6 hydrogens. Okay. And then how many SO4s do I have? I've got 3 SO4s. So now my SO4s have all matched up. Okay, my hydrogens are out of whack and my aluminums are out of whack. So let's go and take a look at my aluminums, see if I can balance my aluminums. So I've got 2 on the right, 1 on my left, but I can just put a 2 here, put my 2 there. Now, as soon as I drop that, I've got to change this number now to 2 a 2. Now my aluminums have matched up. Now the last thing I have to do is make sure my hydrogens match up. So I've got 6 over here on the left side and only 2 on the right side. Well, if I put a 3 over here, okay, over in front of the hydrogens, that will change that 2 into a 6, and now everything matches up and I've balanced my equation. Okay, so that's what balancing equations and how they work. We're going to do one more, okay? And this is going to be kind of a combustion one. So same thing, I'm just going to kind of draw this out a little bit bigger. So we've got CH4 plus O2 leads to CO2 plus H2O. Okay. All right, so I've got my left side my right side chart, and when I add these up, I've got 1 carbon, I've got 4 hydrogens, and I've got 2 oxygens on the left side. So that's an oxygen, that's not a 20. Okay. Then on the right side, I've got 1 carbon, so that's nice. I've got 3 oxygens total, and I'm going to draw these just so they match up. I'm going to put it down here. 3 oxygens total, and then I've got 2 hydrogens. Okay, so the only thing that's really lining up right now is the carbons. Everything else is out of whack. So again, this is going to be trial and error. Okay, so let's go through this and say, okay, my carbons are fine, so let's go and let's try and do the oxygens. Okay, so if I do my oxygens and I have got 3 on this side and I've got 2 on this side, what can I do? Well, let's just say I put a 2 here. If I put a 2 in front of there, it's going to start doing some adjustments. Okay, so I'm going to erase all these and I'm going to do all my adjustments again. So the number of carbons didn't change. I still have 1 because it didn't affect that. But now I have 4 hydrogens. And how many oxygens do I have? Well, I have 2, and then I have 2 there, and I have 4 oxygens. Okay? So at least I got my hydrogens now lined up, my carbons have lined up, but my oxygens haven't. Because I've got 4 on the right side, and I've only got 2 on the left side. Well, let's see if I can try and make the oxygens equal. Well, if I go to the left side and I put a 2 there, if I put a 2 there, that's now going to change this to a 4, and now everything lines up, and this is the balanced chemical equation. Okay, so I know these are not easy. Like when I went through this, it looks like, oh, Mr. Bunning, you're making it seem like, oh, it's just so easy. It's not. Okay, I get it. It's just something that you have to practice as you go through. And again, it's not going to be a make or break. I'm going to ask you to balance a few of them, but it's more important to recognize, if it's balanced or not. Okay, so I will be giving you a worksheet to work on tomorrow.